All the best fantasy maps have a lot of specificity to them. Having a bunch of naturalistic mountains and lakes and islands and towns is cool, but what we really want is for the important ones to be distinctly flagged and to have names, and for their uniqueness to be clearly identified in a way that makes them salient to the reader. The idea of specific locations with important or potentially supernatural forces at play is a big part of what gives a good fantasy setting that larger-than-life aspect. Meanwhile, the kind of maps we're building here don't have any of that so far. Like, yes, they have interesting coastlines and mountains and all that, but none of the features are labeled. And there's a kind of fantasy map generator out there that just goes this far and gives you terrain, and then labeling everything is left as an exercise to the reader. And that's valid. They're trying to do something different from what I'm doing here. And honestly, once you have the terrain, it's not that hard to build labels yourself. Here's that same map after I've spent a few minutes slapping some fairly generic labels onto the terrain. Having the terrain as a starting point is better than nothing, but ideally the map generator should pick out what's an island and what's a mountain, and come up with labels for those itself. And of course the user can edit any of this after the fact, but the goal is to provide a helpful starting point. Having features labeled is also going to help with other aspects of the project down the line. Like, a well-defined sense of what's a mountain peak is going to help us identify narratively interesting magic sites. And features like islands and bays are going to be really informative once we start plunking down settlements. In the long run, we're also going to be able to generate names for each of these features we're labeling, but for now that's still a long ways away. And to me, this is such a cool problem because it really gets the discrepancy between the stuff that we as humans think of as easy and intuitive compared with what computers do well. We can all glance at a map and say, oh, that's an island, or oh, that's a plateau. But those just aren't concepts that immediately make sense to the computer. And so we're going to need to do a little bit of work to get it to understand what we mean. And incidentally, I think this is why some people get so fascinated by the outputs of LLMs, or so-called generative AI. Because the way it's trained on human language means it really does feel like it can behave with that natural intuition for real-world concepts that humans handle so easily. And obviously that's not actually what's going on because LLMs are not built in any way that meaningfully corresponds with intuition. But I think it is why some people end up getting so into repeatedly prompting an LLM and treating the output like they would a human conversation. We're obviously not going to be using LLMs or anything like that in this project, but we'd like it to behave in ways that feel like it's grasping intuitive concepts. So now the challenge for me is to figure out how to capture our intuitive labeling of things like mountain ranges, while still writing a self-contained standalone program that uses standard Python libraries and generates deterministic and explainable output. So, what's going on in this video? For the most part, I'm going to be talking through how I've taken a stab at identifying features of interest on a terrain map, and I'll show you what that ends up looking like. I'm also going to use the systems I'm building here to add in some more cool natural features, like volcanoes and craters, that make the map look a little more fantastical and a little more larger than life. And finally, I'm going to experiment with how this impacts the arcane layer we talked about last week. You might recall that for now, I've been planning to have the sources of magic primarily spring up from islands, mountains, and similar places of natural awe and wonder. And having those more clearly labeled is going to let us get some more fully fleshed out maps of the flows of magical energy. This might feel a little bit more back-end and less directly relevant to map generation than some of what we've done over the last couple weeks. And that's just how this project is going to go. Some weeks are going to be fantasy world building, and some weeks are going to be heavy on the underlying engineering that makes this whole project tick. Ultimately, if you want to put the thalassocracy of the sea elves on the map, you need to know where it makes sense to build the thalassocracy. If you subscribe and stick around, I promise we'll get back to some of the fantasy stuff soon. With all that said, welcome to the third episode of Multiversal Map Room. This week, we'll be adding natural feature identification to the map. Most of what I'm going to be doing in this video has a really similar flavor. We start off with a terrain map, which is a whole grid of pixels with elevations and ocean indicators and a little extra information like sea level. Then we convert every pixel on the map to a binary 0 or 1 value, depending on some specific rules that we're going to come up with ourselves. Then we find contiguous regions of pixels that meet a specific requirement and say that each contiguous region is its own feature. Throughout this project, I've really heavily used the scikit image library, and specifically its measure package. This package makes it fast and easy to group together those contiguous regions. I want to keep this project comprehensible and self-contained and make sure that I understand, the inputs, the process, and the outputs, but also, there's no reason to reinvent the wheel and write my own code to say that two adjacent pixels that satisfy the same rules should be part of the same blob. As an initial example of how this process works, let's start with islands. An island is any landmass that's surrounded by water on all sides. If a landmass is surrounded by water and by the edges of the map, that's more like the mainland. So, the rules for islands and mainland are really simple and quite similar to each other. So let's take this map and color in the islands green and the mainland pink. How does that end up looking? Unsurprisingly, this matches our intuition. Those are definitely the islands and the mainland we'd be hoping for. I've colored in each chunk of island in just a slightly different shade of green and each chunk of mainland in a slightly different shade of pink to emphasize that the code really is flagging each of these as its own separate feature. And so far so good, but successfully distinguishing islands from mainland, kind of the bare minimum, right? This is the simplest rule set we could imagine. And from here on out, the definitions we're going to need are going to be a little bit fuzzier. After islands and mainland, the next set of features we can identify from terrain alone is going to be elevation related. Here's a flowchart for some of the mountainous elevation features we might care about. And you might notice there's a lot of different values to calibrate in here. How high is high enough to count as a mountain range? How smooth does the land have to be to qualify as a plateau? Ultimately, a lot of the work on this project over the last week has been trial and error, testing out parameter values, trying to figure out what gives good results. And part of the definition of good results is just, do I, as someone who likes looking at lots of fantasy maps, think this looks cool and interesting? But part of it is also making sure that interesting features show up in an interesting and variable percentage of the maps. More on that last part later. Anyway, here's that same map as before, but now I've colored in all the elevation features with a little legend off to the right. As you can see, this map has one mountain range, a nearby plateau, a few depressions, and lots of hill ranges. This kind of hill range coverage isn't typical across all the hundreds of maps I've generated in putting this together. This particular map just happened to have multiple regions of moderately high elevation and high variation, which we're labeling as hills. The way we're generating these maps and the way we're labeling these features, no one map really comes out looking typical. And that's kind of the point, right? Ideally, we want these maps to feel very different from one to the next, even if the same logic is generating all of them. One thing this map does have that shows up pretty frequently across all these maps is a couple depressions way off on the edges. You can see those in the top right and the bottom left. And the way we're filling up the ocean as one continuous blob ends up meaning that some areas which we probably should treat as the far side of continents and fill in with ocean end up getting labeled as on-land depressions. And this is kind of unrealistic. I'm optimistic that once we set up the hydrology in lakes and rivers, these will end up being lakes or inland seas, and that's going to lessen their impact and limit the number of these depressions on the edges of the map. If that doesn't work, I might need to revisit how we're filling in the oceans. And finally, as a sample of what it might be like to add some aquatic features, I've added straits and inlets to the map. Straits and inlets for our purposes are anywhere the gap between land masses is long in one direction and short in the other. We don't care if those land masses are islands or mainland. We don't care if one direction is eventually closed off by land. In this little schematic I have up on screen, everything lines up perfectly north, south, and east, west. But of course, that doesn't happen on the actual maps, so we need to check all possible pairs of orthogonal directions. But basically, if the water is long in one direction and skinny in the perpendicular direction, we're counting that. I'm being pretty loose with this definition because my real reason for adding this is that I'd like to use these to inform settlement placement, and so basically we're looking for locations where you could imagine that maritime trade would feel salient. And here's an example of a map with all those straits and inlets colored in orange. You might have to pause the video to check these out because they are pretty small regions. But in general, these are exactly where we'd expect them to be. If we're thinking about these as bodies of water that might have settlements nearby, I think these labels are pretty promising. And I mentioned this previously, but the way that I got all these features to show up at somewhat reasonable frequencies was running the map generation repeatedly for hundreds of seeds to the pseudorandom number generator and checking to see which features showed up when. This let me calibrate up and down, for example, what counted as a mountain range. Here are some summary statistics for the parameter values I've settled on for now. The y-axis shows the share of seeds for which the feature shows up at least once on the map, and the x-axis shows the share of the map each feature covers in the cases where it did show up. Some of these features, like prominent mountain peaks, are single pixels, and so the share of the map that they cover is extremely small by design, so the x-axis here is a log scale. Balancing all of this was tricky because I had to keep checking this graph, but also I had to keep manually going through a few dozen maps for each set of parameters I tried to make sure that we were still reasonably capturing intuitive features on the map. And as you can see, features like islands show up almost every single map, but not literally every single map. More on that in a moment. Whereas features like plateaus aren't guaranteed every time. And this is the kind of variety I think I hope to see. Not every map is necessarily going to contain one of everything, and that makes the outputs look special and unique. That being said, of course, I might revisit this calibration in the future. So, like, what kind of map literally has no islands? Here's what one of those maps looks like. This island-free map generation is only going to happen maybe 2 or 3% of the time under the current setup. To me, this feels like it would be a world where the ocean is vast and empty and foreboding. For now, this kind of map might look a little less interesting than some of the sample maps we've looked at so far. When we only have terrain to look at and no other features, the map just doesn't give our brains much to hold on to. But that's just a function of this project still being in the early stages. It's not actually a problem with the terrain. For contrast, here's a map with very high island coverage, generated with the exact same parameters, but a different seed to the pseudorandom number generator. As long as we just have terrain to work with, this map is going to look more visually interesting than one that turns out to have no islands. But as we add more details to the map, like rivers and forests and settlements, I think the island-free map will end up looking pretty busy too. And finally, while we're here, I figured it might make sense to start roughing out some of the more fantastical features that will make the map look more larger than life. This is something I want to flesh out over the course of the project, obviously, but for now, I'm going to start with just adding impact craters and volcanoes. From a storytelling and world-building perspective, craters and volcanoes make the world seem more dynamic and more hazardous and maybe even more magical. For the purpose of getting this video out, they're also relatively easy to add. Craters, I'm just generating and letting show up wherever on the map, including underwater, with a rim height and overall shape that broadly matches the fresh craters we'd see in the real world. Volcanoes I'm going to cluster together a little bit with a tendency to appear along arcs, and individually they're going to be relatively small on the scale of the map. And remember, we're not going for real-world geological accuracy. We're going for interesting maps of fantasy worlds where we can tell cool stories. So, here's that same map as before, but with craters and volcanoes added. Obviously, I went overboard on the number of craters and the number of volcanoes because I wanted to show off how they look. This is a map of a world where you'd hopefully be telling a fantasy story of something drastic and geologic going on. If we're thinking in terms of a TTRPG campaign, if you're sending your players to visit a third crater or a fifth volcano, and the overarching narrative of the campaign was wholly unrelated to geology or space or anything of that nature, the players might start having some questions. But of course, the user will have the option to tune these parameters up or down, including to the unreasonable level shown on the screen, so you absolutely could map out a world that's actively falling apart. Of course, volcanoes and craters are fully labeled as distinct features, so we can distinguish them from everything else happening on the map, and the other systems we're building can incorporate these. So, for example, we might have different biomes around a bunch of volcanoes, or fewer settlements right inside an impact crater. As an example of those other systems, here's what the corresponding arcane layer looks like for that map. As you might recall from the discussion last week, we're treating points of awe-inspiring natural beauty as sources of magic, and then letting magical energy propagate out from those using an algorithm inspired by slime molds. If we let a random set of islands and mountain peaks and volcanoes and craters count as sources of magic, we already start getting some pretty intricate patterns on the map. I like how we're starting to get some very significant flows through points that aren't volcanoes or islands or anything themselves, but are situated between them. And these flows are only going to get more intricate and elaborate as we account for more varied sources of magic. Anyway, that's all for this week. As always, any feedback on what we're doing here would be really helpful. In particular, if anyone has any suggestions for other dramatic terrain features like volcanoes or craters that it might make sense to add, let me know.